Okay, here you are, 5.3, this is the next part. I'm solving logarithmic equations. We did solving exponential equations in 5.2, so this is logs. So again, you're solving for a variable. First, you're going to simplify to a single condensed log. Use your properties that we just talked about. Then you're going to change to exponential form. That's messy. And then we're going to solve for x. Now we have one more step, but I want to kind of look at something really quick to kind of refresh our memory. I'm going to draw your parent function y equals log base b of x. We know we have a vertical asymptote at h equals 0. We have 1, 0, and then the other one would be b1, depending what it was. So what we did here, I'm going to draw my axis. I have an asymptote here at x equals 0. There it is. Okay, if I draw my graph, it's going to go through here and kind of go like this way. Now, if I talk about the domain of this graph is, as far as I can go to the left is 0. Okay, so all my values have to be greater than 0. And it's kind of important to think about that because when it comes to solving log equations, we have to be careful and make sure that we pay attention for our domain. So let's look at this part down here. It says domain restrictions. If you look at our graph, logs can't have an argument. Now this is the argument part of any negative numbers. Nothing over here is seen of the graph. We don't use that part. Okay, so no negative numbers or 0. It's because of this asymptote, you don't get to be on this, touch this 0 at all. You get close to it, so 0. So your argument, when you're done, your x value, whatever that answer is, you got to make sure that when you substitute it back in, you're not getting a negative number or 0 in the argument. So therefore, that goes with letter D here, which you don't like to do, but we need to check for extraneous solutions. Now, it's really simple. It's probably even better than what we've done before. So I'll show you how to do those, and we'll go from there. Okay, so let's try number 1. Okay, number 1. First, we have to simplify to a condensed single log form, which we don't have. We have numbers on there that we need to get rid of. So we're going to get rid of this -10, negative log of x plus 1 equals -7. Get rid of the negative in front of the ln x, divide everything by -1. And we want out, because remember we don't want any coefficients. Let me go from here. Now it says to change the exponential form. So let's change that. Our base is e, don't forget. It's ln, it's understood that. So we get e to the 7 equals x plus 1. Just like when you're doing the other 5.2, you get the x by yourself. E to the 7th is just a number. So all I got to do is subtract 1 because I want to get x by itself. Well, I can combine these because I don't know what e to the 7 is. So I'm going to e to the 7 equals 1, and and it's equal to x. Now you'll have to use your calculator to get an answer. So let's pause and do that. Okay, so I'm going to use my calculator here. I don't want to go. So go to the home screen. We have e. So if you hit second ln of the ln, you get that pop up, e to the x, e to the empty box there. Put your exponent there, subtract 1, and then round 3 places. So we get 1,095 and 633 thousandths. Okay, so there's my answer. Now I got to check first, and this is how simple it is checking. Now it says the argument up here, if we look up here from we had before, it cannot be 0. or negative. And we said earlier domain had to be greater than 0. So all you're going to do is you're going to take your argument. Well, this argument right here is x plus 1, right here. Okay, so I'm going to check. I'm going to take my argument, which is x plus 1. That has to be greater than 0. Well, now I'm going to substitute x in there. What is x? Our x is 1095.633. I'm going to add that to 1. And the question is this greater than 0? Yes. So this is a solution. Okay. Let's go on to number 2. I need the bases to be the same, which is here. And so in order to get some kind of solving for x, I've got to get rid of both those logs and put them together to change exponential. So it's base 2. So I'm going to do log base 2. And I have x times x minus 7 because I'm using my properties. And that's a plus, so I multiply the arguments. Equals a 3. Now I'm the form where I can change the exponential. If you mess yourself up, go over here and write the base so that you go, oh, I have the base. So that means if I'm changing the exponential, the base is raised to the exponent and it equals the argument. Okay, so that's all I did. Now I'm going to change this to 8. I'm going to distribute this. I see that if I've solved for x, I have a square there, so I have a quadratic. So that means factoring, quadratic formula, anything that we need to in order to get the solution. So I'm going to move the 8 over. Okay, I'm going to pause, and you're going to find your solutions. Okay, after doing all my math, I have 2 solutions in here, but I have to check them. So I'm going to check with the arguments. The arguments, again, are the x and the x minus 7. You must check in both, and the solution must be true for both in order for it to work. So I'm going to take the first one, and I'm going to do x has to be greater than 0. So take the argument and make it greater than 0. No matter what the argument is, make it greater than 0. So here's x is greater than 0. Now what is x? I'm going to do x equals 8 first for my solutions. So is 8... different color, is 8 greater than 0? That's true. So it works for that one. So now I got to take my other argument, which is x minus 7. Is that greater than 0? So I'm using this argument here. Again, I let x equal 8. Is 8 minus 7 greater than 0? Yes, that is true. So therefore, x equals 8 is a solution. Now you have to try x equals 1, negative 1. So take the first argument, which is x. So I have to say that x has to be greater than 0. Is negative 1 greater than 0? No, that's not true. So therefore, this is not a solution. So stop. You don't have to try the other argument. You already proved that it didn't work. So this doesn't work, and that's your extraneous solution. Okay, so this next one, I want you to put it together, a single log, and then come back to the point where you're getting ready to factor. We'll see what you got from there. Okay, so one thing nice about this one, if the logs are the same on both sides, and it's single log, then I can drop the logs just like I can drop the bases and let those arguments equal to each other. So I did that, then I distribute, and then I moved everything to one side. Okay, so I want you to FOIL it. Factor it and see what your 2 solutions are. Okay, so these are my 2 solutions. X equals 2/3 and x equals negative 9/8. So I want to make sure that I check those now. So I wanted to check with you. So I'm going to check first the 2/3. So I'm going to go to the arguments. So here's my check with 2/3. The first one I'll do is the natural log of x, just the x. So x has to be greater than 0. So is 2/3 greater than the 0? Yes. So it checks and works with that one. Now you got to use the next one though. The next one is 24 plus x. Again, go to the argument. 24 plus 11 is greater than 0. And so now I have to substitute 2/3 into the 20 with the 24x. So I have 24 times 2/3 plus 11 is greater than 0. Now don't worry about trying to do the math. This side has to be greater than or equal to, greater than 0, so it has to be a positive number. So if you multiply these together, you get a positive number, plus another positive number. That's positive, so you get a positive number. So it's positive greater than 0 always. So this works, so therefore this is a solution. Now let's check for the negative 9/8. So we have first x is greater than 0. Negative 9/8 is the x value. Is that greater than 0? No. So therefore that does not work. That's your extraneous solution. Okay. Now, I just want to caution you, just because you get a negative a lot for a solution, negative answer doesn't mean it doesn't work. You always have to check. And you will need to check because I will take points off if you don't. So check. All right, last one. We have the ln. I need this moved over. So that'll be the ln of x plus 2 minus the ln of 2x plus 5 equals 3. Okay, so division, because I need a single log, so that's going to be division, and that equal 3. Remember, my base is e, so now I can change this to exponential form. So that's going to be e cubed equals x plus 2 over 2x plus 5. Now I got to solve for x. The problem is I have this fraction, so remember, if you put this over 1, we can cross multiply these. So we get e cubed times 2x plus 5 equals x plus 2. Now I need to solve for x, but if this was like 4 times x plus 1 equals x minus 2, you would distribute the 4 first. Well, this is still e cubed is just a number, so I'm going to distribute it. So I have 2x e cubed, and then 5e cubed, and that equals x plus 2. This is a number only, okay? This is a number only. This has an x, and this has an x. I got to combine x's together. So to do that, I am going to move this x over by subtracting x. Combine like terms I cannot, so that will be looking like this. This is a number here, so I'm going to have to move this over. Those are not like terms, so I cannot put them together, but I can do this. Now the thing about this one is that I need to solve for this x. Remember, if they're in both of them like that, you're going to factor out a GCF so you can see if you can solve for x. So the GCF here is x, so I must take out an x, and that's what I need to solve for. So if I do what I like to do and put underneath here when I teach all this, that cancels this x, so that's 2e cubed, which is a number, and then negative minus, and then x over x is just 1. So now what I want to do is solve for x. Now I want to divide by x, so I have to get x by itself, so I got to divide everything by this number. Remember, 2 times e to the cube minus 1 is just a number. That cancels. And so this is my x value. Now I want to see what that equals to, so I'm going to go to my calculator. So I'm going to browse. And so if you don't have to use a fraction key, but if you don't, then you're going to do 2 minus 5. Make sure that you are using parentheses. It will not work. You will get the different answer if you do. You can use the fraction key, and you don't need the parentheses. Make sure you write it oops, I forgot to put parentheses on the bottom. 2 times e, again, always put in parentheses, minus 1, close your parentheses, and enter. So you get negative 2.512513. Okay? Let me move this out of the way. So for our answer, we got, according to my calculator, we got x equals negative 2.513. Now we have to check that. Okay, so let's check. I'm going to do the first argument of x plus 2 right here. That has to be greater than 0. Well, my x is negative 2.513. If I add that to 2, does my answer become greater than 0? Well, this answer, when I add these two, is actually not a positive number, a negative number. Negative 0.513 to be exact. Is that greater than 0? No. So this doesn't work. So therefore, this answer is no solution.